Okay, so want to introduce matter. So want to introduce matter, phases of matter, right? So we just want to introduce phases of matter. So phases of matter, right? So phases of matter, right? So what is matter? So matter is any substance or material that is mass and occupies space, right? So it's any substance or material that is mass and occupies space, right? So according to the kinetic theory of matter, right, matter is made up of tiny particles in the form of atoms, ions, or molecules, right? So there are three states of matter that we're going to look at, right? So first of all, we're going to look at solid phase. So we're going to look at solid phase, right? So, so first of all, good, sorry, solid phase. So in the solid phase, matter is a fixed shape, right? So matter is a fixed shape and volume, right? So matter is a fixed shape and volume, right? And when heated, so when we heat the atoms of the solid, they vibrate about their equilibrium position. That's a point you need to note, right? So we know that when heated, solid phase, when heated, right, atoms or particles, they vibrate about their equilibrium positions, right? They vibrate about their equilibrium positions, right? So they vibrate about their equilibrium positions, right? With increasing amplitude as heat energy is applied as kinetic energy. So the particles will have vibrational kinetic energy, right? So the particles will have vibrational kinetic energy, right? So it will be vibrational kinetic energy with increasing amplitudes, right? So the amplitudes depend on the amount of heat applied. So it depends on the amount of heat applied, right? And so at melting point, if you continue heating, when we reach melting point, so at melting point, right, we know that the heat energy being supplied does not continue to increase the kinetic energy of the particles, right? Instead, that heat energy is now being used to break down the solid phase into liquid phase, right? So that's what happens at melting. So the temperature does not change at melting. Temperature of a solid does not change when you're melting. Instead, the energy is being used to break down the intermolecular forces in the solid phase, right? So so when we break down, right, a solid into liquid, we've increased the potential energy, right? Because they are more free, right? The particles are more free to move, so we increase the potential energy, right? So so that's what happens. So at melting point, right? So we say temperature. So we know that does not change. So at melting point, temperature does not change, right? At melting point temperature. Instead, the energy is used to break down the intermolecular forces holding the solid phase together. So let's look at liquid phase. So liquid phase, right? So liquid phase. So matter is a fixed volume. So matter is a fixed volume, right? But no fixed shape, right? No fixed shape. It takes the shape of the container, in other words. So there's no fixed shape, right? So when we heat liquids, right, the atoms move about freely when we're heating a liquid, let's say water. So the atoms or the ions or the molecules will be moving about freely in the liquid body, but they are still close enough to experience the interatomic forces, right? So they're still close enough to experience the intermolecular forces, such as in water, the hydrogen bonds, right? So the molecules are moving, but they're also bounded, still bounded by the hydrogen bonds. And they still have a potential energy associated with that, with those forces, right? With those intermolecular forces, right? So the kinetic energy will change corresponding to the to the temperature, right? So when we continue heating, right? So the 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 molecules in the liquid will gain enough energy to finally escape into gas. So that's when we have what? We have evaporation. So if you continue heating, the molecules have enough energy to finally escape as a gas, right? So let's look at the gaseous phase. Gas phase. Okay, gas phase, right? So So eventually, if the temperature of the liquid is increased to its boiling point, right? If you increase the temperature of the liquid, right, to boiling point, so we reach a point where the atoms now begin to escape, right? So we reach a point where the atoms now begin to escape. So let's write. So this is no fixed volume, no fixed shape. So we know that gases have no fixed volume, they have no fixed shape, right? So we are heating a liquid, so at boiling point, right? That's when we now have conversion from liquid to gas. When we would have overcome the interatomic forces, right? So we've broken the bonds for the gas, for the molecules to escape as a gas, right? So this is a latent heat of vaporization. We'll look at it when we're doing thermal properties of matter, right? That's when we do a latent heat. So it's a hidden heat. It's like heat that is required at phase change, right? To change phase. Okay. So so that's what about gases, right? So they are free, so they move about freely, so they are in random motion, because they have escaped the intermolecular forces, right? So when we're looking at phase change, let's just look at phase change quickly. So phase change, right? So we have gas, right? We have liquid, we have solid here. So we know that, excuse me. So from liquid to gas. So no, from liquid to gas. That's what. That's evaporation, right? Evaporation. From liquid to gas, it's evaporation. From from gas to liquid, that condensation, right? That condensation, right? And then from liquid to solid, so that's freezing, liquid to solid. And then from solid to liquid, we know that's melting, right? So that's melting. And then from solid, right? From solid to gas, so that's what we call sublimation, right? So sublimation, right? Okay, so that's on on phase change, right? On phase changes. So these are the changes that happen when we're changing phases, right? So I want to look at evaporation. Now I want to look at evaporation. Evaporation. Okay, so what is evaporation? It is the escape. So this is the escape, right? So this is the escape of the more energetic molecules. So of the of the more energetic molecules or particles, right? Particles from the surface of a liquid, from the surface of a liquid. So that is that's what evaporation is. So it's a change of phase, right, from liquid to gas, right? So phase change from liquid to gas. So that's what evaporation is all about, right? So so what happens in evaporation? So the upward moving liquid particles near the surface of the liquid, so they may have energy, enough energy to escape completely. So that's what happens. So the molecules may have enough energy to escape completely, right? So A, they may have enough energy to escape completely, right? Or B, escape to a point where they can be repelled back, escape to a point where they can be repelled back, right? That's what happens, repelled back, right? Or C, move a little. So C, they can just move a little way up before other particles in the liquid pull them back. So that's what happens. They will move a little way up before other particles in the liquid pull them back, right? Move a little, right? So we can say move a little way up before other particles pull them back, before other particles pull them back, right? So that's what happens. So there are factors that affect the rate of evaporation. So we're going to look at that. So the factors that affect the rate of evaporation. So we know that the rate of evaporation, right, depend on, right? So A, right, we know that or surface area. First of all, it's surface area, right? So increase in surface area, So we've increased the rate. So if the surface area is large enough, so more molecules are exposed. Like if we have a large surface area with more molecules exposed at the surface, so we've increased the rate of evaporation, right? B, right? We have the issue of temperature. So with temperature, right? So with temperature, right? So increase in temperature, which means we've increased the number of more energetic particles that can escape. So right. So increased temperatures, right? Right. We have more number of energetic molecules that can escape if we increase temperature. So we end up with greater number of more energetic molecules that can escape, right? So, and then the C, so the other factor, so decreased pressure, right? So we've decreased pressure, right? So what happens with pressure? So if we have particles on top of the liquid surface, right, we've decreased in evaporation because of the particles in the liquid won't be able to escape freely, right? So we have to decrease pressure on the surface of the liquid, right? So and then the other factor, right? So it's humidity, right? So humidity, if we have Humidity is a measure of amount of water vapor near the surface of the liquid, right? So we have to have a greater gradient, right? A diffusion gradient, sort of like, right? So we have to remove the water vapor on the surface of the liquid such that the escape become more favorable. So that's what we mean by humidity. So evaporation occurs at all temperatures, but fastest at high temperatures. So that's what you need to know. So evaporation occurs at all temperatures, but at increased temperatures it becomes faster because we have more number of energetic particles that can escape at high temperatures, right? So and also when evaporation occurs, right? So what you need to know is if when evaporation occurs, so the molecules that are left behind, they are cooler. So it cools. When evaporation occurs, it cools the remaining molecules, right? So that's what you need to know. The remaining molecules are cooled down. Right. So let's look at boiling. Now I want to look at boiling. Okay. Boiling. I want to look at boiling. Right. So what is boiling? So this is a very rapid. So it's a very rapid form of evaporation. So it's a very rapid form of evaporation. That's what boiling is. Right. So when a liquid boils, water vapor bubbles form deep inside the liquid. Right. So water vapor bubbles form deep inside the liquid body. So they form deep inside the liquid body and expand. Have you seen a liquid boil, water boiling and expand, rise, and burst? So they expand, rise, and burst, right? To release large amounts of vapor, to release large amounts of vapor. So that's what happens in boiling, right? You've seen water boiling, so those bubbles that are bursting, so those bubbles that are always bursting. If you've seen a liquid boiling, right, which I assume you have, so this occurs at a fixed temperature. You know that it occurs at a fixed temperature. So it occurs at a fixed temperature, right? Fixed temperature, which is called the boiling point. Right? That fixed temperature, which is called the boiling point, right? So at BP, so what makes a liquid boil? So we know that at BP, right, the vapor pressure. So remember those bubbles have to burst. So at boiling point, the vapor pressure must be greater, than the atmospheric pressure. So it must be greater than the atmospheric pressure, right? Because for the bubble to burst, it has to push back the atmospheric pressure, right? Remember, so if a balloon, remember, if for a balloon to burst, the pressure inside the balloon is to be greater than the atmospheric pressure outside, right? So that's what we mean. So at boiling point, the vapor pressure must be greater than the atmospheric pressure. So the vapor pressure is to be greater than the atmospheric pressure. So that's what boiling. So boiling, it occurs throughout the liquid, right? So let's just do a comparison. Right? We just do a comparison between boiling and evaporation. And we just draw a table. Right. So let me just draw a table here. We have evaporation, and then we have boiling here. Just a comparison of what happens right here. Okay. So first of all, we know that evaporation occurs at any temperature. So evaporation occurs at any temperature, right? So regardless of atmosphere, whereas in boiling, boiling, we know that boiling occurs at a fixed temperature. Occurs at a fixed temperature. So this is called the what? The boiling point, right? Called the boiling point. And then secondly, right? So the secondly, we know that uh, so it's a similarity, right? So it's a phase change. Phase change. So they both involve phase change from liquid to gas. So we know that from liquid to gas, right? So that's what you know, right? They all involve phase change from liquid to gas. So that's a similarity, right? Third point, right? Third point. So as I mentioned earlier, evaporation occurs at the surface. So occurs. So it occurs at the surface, right? And then boiling occurs throughout the liquid. So the whole liquid will be boiling. Occurs throughout the liquid body. So the whole liquid will be boiling. And then lastly, right, as we mentioned earlier, with evaporation, right, there's cooling of the molecules that are left behind. Cooling of the molecules. So there's cooling of the molecules left behind. But in boiling, there is no cooling, right? Molecules, so molecules left behind are not cooled, right? So in other words, the temperature remains the same. We remain at the boiling point, right? So that's a that's a comparison. That was a comparison between boiling and evaporation, right? So that's what you need to know about matter. So that was just an introduction to phases of matter, right? So that's any questions? Any questions? So if there are no questions, thank you for your time. Meeting next time.